Saturday morning is very hard. Even I would not sign up for a Saturday morning meetup session, but you guys are awesome. So again, thank you. And Maruthi, solution architect with ClickHouse, been with ClickHouse for about 4 months. So I'm one of the newest employees, and later Stan is going to come in as one of our senior employees, 2 years old. Why I'm saying this is like our company is pretty young, and like we are growing pretty fast. And over the next couple of slides, you'll understand why and what we are doing in the market, not just in Vietnam or ASEAN, also globally, and how users are actually using us. So that's me. Again, close-up photo of myself, if you want. And feel free to connect with me on LinkedIn on that side, and also write blogs around data engineering, data quality, AI, ML. It's kind of like my area of specialization. So that's my blogs. Feel free to connect, say hi, and would love to hear from you guys what you're doing on the AI, ML space, and also in the data management space as well. Just move on to the next one. So for my session itself, I just want to give a quick intro of ClickHouse, and then go into like, there's some magic about ClickHouse, and how does it does all the things that we're gonna say. And the last part is, what are we doing in the AI ML space, because that's kind of one of the bigger space a lot of people are talking about, and it's something that we are laying foundations for maybe for the next decade. Kind of like most companies are trying to adopt it. I know the question already came up, but how many of you know about ClickHouse before coming for this event? How many of you have already used ClickHouse? Wow, okay. Use ClickHouse in production except for this team. Who else has done it? Okay, this one. Okay, you guys are excluded from this. Okay, so the thing is, yeah, if you think about ClickHouse itself, right, the name is kind of like getting popular for the rest of the world, but people who are in the data space, most of them have already heard about ClickHouse, because ClickHouse was initially prototyped in 2009 for Yandex. Yandex is a search engine for Russia, so they actually kind of prototyped something built from scratch, and it was actually designed for very simple task, is to ingest large volumes of clickstream data, and then being able to aggregate it as quickly as possible, like low latency queries with better efficiency of compute, right? And then in 2012, they went into production. By the time they went into production, they actually added a lot of other additional features, and then it became a database by itself by 2012. By 2016, we actually open source the product. And then if you look at it, 2021 is when the company I represent, ClickHouse Inc., and San over here was formed 2021. And our official enterprise product was actually launched in 2022. So we are pretty young company, and what we're doing, guys, feel free to just come in, have a seat. And then, but if you look at our adoption itself, is actually skyrocketing. There's a lot of users using it. The key reason is like on the technical aspects, I'm going to cover in the next couple of slides. And this slide is slightly outdated on this part. We just crossed 40,000 GitHub stars, and it's still continuing to grow. And our community, as always, you guys, hopefully will become part of this 200,000 and actually expand things more for us in the Vietnam market as well as ClickHouse users. So what are the kind of key things about ClickHouse, right? ClickHouse is actually a columnar database, but we are SQL first. So if you're familiar with SQL, one of the oldest scripting or languages that's out there communicating with databases, you can actually use ClickHouse. You don't have to learn something new to work with us. The next part is we can process like data pretty fast. That means low latency queries with less compute. So you don't have to actually provision massive clusters to kind of like compute billions of records. You just need small instances. So very efficient in that. Next thing is we specialize in working with petabyte scale data sets. So we actually have a really good compression mechanism. So actually, once you start ingesting, you don't have to worry about how or what kind of things that you need to do for compression. We kind of handle everything by ourselves on our side. The last part is scale. So you can actually horizontally and vertically scale the system as big as possible. As I said, it was designed for internet scale companies to actually use for clickstream data. So what are we continuing to build for in ClickHouse itself? So when we actually looked at the market itself, like when everything started with the first databases and applications, we actually had it's all relative numbers where like you had enough queries, but you didn't really have a lot of data. But if you actually just go back last 10 years, right, with the big data wave, you had so much data being generated and collected, but you didn't have the mechanism or the way to kind of query all of those data. So that's where we were at. But as we move forward now, the volume of data that's being generated is actually continuing to grow, but also the kind of queries that we're executing is also scaling up. That's where we see the future to be, especially like, not the humans have grown exponentially, but now we have AI agents. Just imagine every single developer or every single business user works with 10 or 20 different AI agents, and all of them need access to your data. How do you kind of enable all these people to get access to your data and all the agents to get access to data? You need to have a platform which can actually do low latency queries. At the same time, you don't like provision an entire data center just to support a single chat interface. So you need to find some balance. So that's where we are focusing on building high throughput, high volume queries with low latency response with low resource consumption. And within the data space, just looking at it, like one of the things that we don't focus on is OLTP. So any transactional workloads, we're not into it. So we focus on the other tiers of data, where you focus on your analytical workloads, your data warehousing aspects, and the larger part, which is the observability piece at the bottom. Because there's a lot of logs and traces that's being generated, especially again, going back into the AI ML space. There's a lot more traces that needs to be tracked so that you know like what your AI is doing, because it's not like a human being where like you can go back and ask them like, hey, what have you done? Explain the last 10 steps you have done to get to this particular outcome. Your AI is going to be like running queries at scale and making decisions at scale. You need to be able to keep track of all those things, and when you need it, you should be able to access it. So we call it the digital exhaust, because there's huge volumes of data being generated, collected, and stored. But then the value that you get out of it is minimal, but you still need it because you need to figure out what's happening in your systems. And just looking at like who are the ClickHouse users globally, that you can think about any major companies, ClickHouse is using it, and I see a lot of smiling faces on this side of things. But yeah, like pretty much internet scale companies, on-premise, like FSIs, anything you can think about, they're already using a ClickHouse users, and hopefully like we can start adding the logos of your companies, either the ones you're building or you're working for. Hopefully by the next time you'll have those logos here as well. Do let us know if you want to add your logo there as well. So I've said a lot of things, right, but what makes ClickHouse unique? Because we always boast ourselves to be a very fast database, and also a database which can store large volumes of data. At the same time, use very less resources. So how do we do it? It's not magic actually. There's two main things, really, two main topics that you need to remember, take away from today's session, right? Is the first thing, how we store data inside ClickHouse. That's the first part. So in ClickHouse, we have a concept of what we call table engines. Table engines are the way that we collect and store data in the database itself. So the main thing is called merge tree. Merge tree is not a single thing. It's a family of table engines, or you can just talk about storage mechanisms. So that helps you store data inside the database efficiently. Like one thing is having like large throughputs of information being collected, and also compressing it at the same time. So what happens in merge tree itself, like every time you do an insert, we create something called as a part. Part is just, imagine it's kind of like a folder structure inside your Linux or wherever it is. And then we write all that data inside that particular part. And every time you insert 1,000,000 records in each part or 1,000 records in each part. It creates a folder and just leaves it there. And then those data can be queried anytime. But what happens is the merge tree engine on the background process, if you look at it, this runs as a background where it actually does compaction. So it looks at, okay, these two parts are the same, or they have similar data, let's bring them together. And then they start merging and merging. That's why the term merge tree comes in. So we start continue to merge them until they reach somewhere like 150 gigabytes. That's like a few hundred million rows to a few billion records, depending on what happens. So during this process, one of the things that happens is anyone want to guess what happens when the merge tree merges parts? All right, when the merge tree merges parts, what happens is the data compaction happens, where all your compression takes place. Because we are a columnar database, we're going to compress and compress. So from a few hundred petabytes, you can actually bring it to a couple of petabytes. So all this is running on the background. So when your users are querying this data, they can still query it. Just assume like these two parts are being merged over here. On the background, we set these are active parts. And this will be the new part that's being created. This will be set as inactive. So when the query goes in, it needs to read the data from here. It will continue to read. But then once the merge is completed, this will be set as inactive and this will be set as active. So the process runs on the background, so there's no impact for your users. And at the same time, as your system continues to run, the compaction continues to happen. So your resource consumption is always going to stay low as possible. And we're going to maximize your resources that you allocate. So that's the key part of merge tree itself. The next part is, how do you read the data out efficiently? How do you ensure that with less resources, we are able to retrieve the data that is required? So one of the key things that we look at is like, how do we efficiently figure out what are the pieces of information that is needed for your query? Because you might have like few hundred billion records, right? You don't need all the record for that particular query that you're executing. You just need specific parts of the record. So how do we do it is a couple of ways that we do it. So first thing is each part, within a part, we create something called as granules, which you see over here. So granules contain about, as a kind of a virtual grouping of your data, which contains about 8,192 records. So in these granules, what we do is we kind of set kind of virtual pointers, which loads like what is the ID or the creation date or anything. So when you write the query, when the query hits the query planner inside, it goes and figures out which are the granules that is required for this query first, so that it does not need to scan the entire table. It will skip through everything. For example, this is one granule, this is another granule, there's another granule. 3 granules in this particular table. It goes and figures out, okay, which granules do I need for this query? And it'll only retrieve those granules. So that means even if you have billions of records, you might just need 1 million records. So it's only going to retrieve those granules that is required. Since this is actually a virtual index, it's very lightweight. So you're not loading a lot of information into your memory and then trying to figure out. You're just loading like a sparse index with just a couple of values inside, even with few billion records, and you're able to efficiently read all this information. And again, since it's a columnar database, we don't have to go through all the records. Depending on your select query, unless you're doing select star, which you should avoid, you're going to mention which columns you want to query. So we're going to retrieve only those columns. So overall, the volume of data that you're going to put inside your memory to process or do your computation is going to be pretty low. That's the second way that we actually make sure that with less or low resources, we still be able to give you like better performance. So those are the 2 kind of like magical items that ClickHouse comes with out of the box, which kind of helps you achieve low latency queries, at the same time high compression and scale as well. Before getting into the AI ML space, like anyone has any questions? Seems like everyone is ready, like at least the gentleman in the front row know what they do. Oh, wow, okay, shoot it.
Okay, so you mentioned about virtual index.
Oh.
Okay, so could you elaborate a bit more? What did actually, how you design, because like the concept, I did a quick check on the internet and no clear explanation.
Yes, good question. What I'm going to do is I'm going to take it offline and I'm going to cover this in detail because it's going to take time on that. Okay. But it is a very important thing. Like, thank you for asking. We will actually take it offline because I still need to pass to the rest of them. They're going to kick us out pretty soon. So at a high level, we actually cover 4 main use cases. Look at the digital exhaust is kind of like the biggest use case because of the high compression ratio that we actually provide. A lot of observability use cases are currently running on top of ClickHouse because just imagine your systems are going to churn out few hundred millions or trillions of records a day and you need to like store it efficiently. So that's the biggest use case for us. Next thing is real-time analytics. So when I talk about real-time analytics, as you start streaming in your data, as I showed in merge tree itself, as you ingest your data, the moment it lands inside the database, you are able to run a query on it. because everything else runs on the background. All the merge operations, the management, the housekeeping job runs on the background. The user does not have to worry about it. Next one is business intelligence. Like now, I'm going to show you a demo of what we do inside ClickHouse currently. How do we make use of AI agents to enable all our business users? We are a young startup with 200 odd people, and we are running a global company. So how do we kind of try to maximize our time by leveraging on AI? So I'm going to show that example along with the last example, which is on the ML and AI and what we're trying to do there. So when we started looking at, when we built the database, it was meant for clickstream data, then we evolved into analytics and observability. But the last 2-3 years, there's a lot of requirements around the ML AI space, especially around the AI space. This comes to another question to all of you. If you just raise your hand, which companies are not using AI? Or like, for example, ChatGPT, who is not using ChatGPT? Seems like everyone is using with a smile, like, thank you for raising your hand. So internally, are you building any RAG-based applications or any chat interfaces using agents? Maybe I'll ask this question another way. Who is not building anything with AI agents or any LLMs? You're not building anything with AI agents. I need to talk to you later. But yeah, so then we started like looking at this, right? Like there's a lot more users who are trying to get into the space where they want to build a platform to either support current requirements, like you want to build an AI agent, a chatbot now, or they want to build a new platform which down the line they can actually use it to build an AI agent on top of it. Because like enterprises and larger organizations, you can't like, today I use database A, tomorrow I'm going to use database B. Like you need to plan. There's going to be a lot of refactoring structure. So when they are trying to do a modernization or they're going to make a change to the database, right, they actually think about building a platform, a data platform which can help them build all these future-driven use cases or future-focused use cases. So for us, we looked at it like, okay, we are having a database which does a lot of stuff. So what are the things that we can address within the ML AI space? The first thing we look at is like the data infrastructure itself. So mapping back into like, okay, we can have high throughput data ingestion that we can handle high compression. Is it required for the AI ML space? Yes, it is required, because you're going to like capture a lot of the different interfaces from your source applications, your user interactions, and capture and store all that information. You need to have a system that can do it. The next part is storing is one thing, but you need to process those data. Most of the time, the raw information is too humongous. There's a lot of things that comes in, and you might not be able to directly use that for your business use case. Either you're building a recommendation engine or a RAG-based system. Just having billions of records, you introduce it to them, they're not going to work. You need to process and be able to serve them. So there comes your vector searches or your feature engineering for your machine learning models to support training or inference. The next part is operations. This is becoming more popular, especially with the RAG-based applications and the AI-based, agent-based applications, right? Because like in observability space, you like look at like logs, traces, profiles, and metrics. But then when it actually comes into the AI space, you need to look further into the traces part of things, where you're not just capturing like events and from one point to another point. You're also looking at reasoning aspects. What does an AI agent does when you ask a question? Is going to go through multiple steps, and each step is sequential, like based on the previous steps outcome or decision, the next thing goes. So when you want to fine-tune your system or like fix an issue because you're asking some question but it's giving you irrelevant responses, you need to be able to go and fix it. So you need to capture all these traces. Just imagine a single agent can produce like a few 100,000 traces within a day. Yeah, you're going to have multiple agents and multiple users using this agent. So for you to be able to capture all that information and understand what's happening, you need to have something that can do it. So from an LLM ops perspective, again, you need to have a system which can use your resources efficiently. The last part is you have all this done, but you need to be able to deliver these things. So this is what we call it as designing for the agent space. Because now maybe you might have 100,000 users using your application, but just imagine out there's most of the applications are coming with agent-specific things. Even just using ChatGPT or Anthropic or whatnot, right, like Claude AI, they are going to be calling. So they're not going to make a single call. I'm going to ask a single question, but they're going to like parallelize, think about 20 different aspects of the same problem or the same query, and they're going to hit your platform. So I'm instantly like 10x myself querying the same system. So how are you going to be able to serve all those users of the future? Because your customers might not grow exponentially, but the interface that your customer uses to engage your services is going to exponentially grow. I'll call it explode as well. So then your system needs to be able to deliver and support those things. So these are things that we looked at, the 4 pillars of what we can do and how it can support. So then we kind of compressed it, and when we talk to users, we look at like, you're building for the AI ML space, so what are the things that you're going to look at? First thing is, how do we kind of unify all your data? So you're going to have a lot of different sources of information that's being generated, stream, batch, or anything. And then you need to acquire all this information. For an example, just looking at fraud detection, right? Fraud detection historically has been like looking at just like purchase or transaction behaviors. But now with the digital space itself, fraud detection is getting more complicated, where users look at all your past transactions, like how much money you've spent, how frequently you've spent. Apart from that, they also start adding in information that comes from your logs and traces. That means like, what is your behavior on the app every single time you go in? Does it match? Is it the same as the past? What is the usual time that you go in? All those information goes into a feature to predict whether it's a fraudulent transaction or not. So now you don't just rely on our transactional information, but you're also looking at your observability information to combine and get to your outcomes that you want to get. So you need to be able to bring all those information together. The next part is, what are we trying to serve just within the AI ML space? From your operations to building search engines to RAGs, there's a lot of things that's currently being built, and the space is evolving. So as recent as this week, Google announced a couple of advances, like where they A2A, which is like agent-to-agent protocols. Previously, we had MCP, which was popular the like last 2 months, or last year it was more on RAG-based or CAG, context augmented generation. So we are seeing things evolving very fast. So the use cases on top is also going to evolve a lot more, and I'll call it more of a maturity. Like more maturity comes in, how can we use AI to kind of deliver value to our users? So what we thought was like, we already have these 4 pillars and we have different features inside. How do we kind of address as a unified platform? Because now we want to create a funnel where like you bring in all information and be a single point interfacing for all your use cases. So over here, what you see is just some of the features that we have already built, implemented, and we're also expanding into it. As recent as our JSON data type, which is G8, and we're just improving on top of it as well, because we see a lot more usage of JSON data type, especially for LLMs. When you actually compare like token generation, just sending in a blob of text versus you sending a semi-structured JSON data type, the token usage actually goes down. Just a small hack that will improve. So that's one of the other reasons we are using JSON support on that, and we're also implementing our full text search. We already have implemented our vector search as well. So you can kind of like expand the platform. So we are also planning to mature, and we just recently launched our MCP server as well. So if you're already using like any Claude or anything now, today you can just copy our config. We can actually go test it out. We have also set up a playground for users to kind of like use the MCP server to test out how it works before you kind of make use of it for your business as well. So my demo is going to be around that. Just want to go through this. And the reason why we are also kind of like going and talking more, right, is like if you just look at the models, like how many of you have heard about OpenAI before ChatGPT came about? So I hope all you guys are in the NLP space. Yeah, so like 15, 20 years ago, like not 20 years ago, 15 years ago when I was doing NLP work, like I used to do some research on that. I used to write like 100 lines of code to just ingest a text file, process it before it is ready for my sentiment analyzer. Like like 100 lines, like minimum 100 lines of code, right? The amount of process that you need to go through. But now with ChatGPT and everything, is like, if you use Hugging Face transformers, you just write 2 lines of code, you have your sentiment analyzer done. As simple as that. So the space is evolving, the models are getting bigger, better, and then the infrastructure that's supporting these models are also scaling up very fast. Like, you might have heard about Grok and NVIDIA, like they are competing in different spaces. One is for training, another one's for inference itself. But our data platform is still kind of like, if you're using Postgres, is amazing. I love Postgres as well. No offense on that. But then it is not going to be able to scale, especially if you're using Postgres for large volumes of OLAP queries. I'm pretty sure you're struggling. If you say you're not struggling, then we need to have a chat on that. But that's where we are looking at. We're like, how do we get value out of data, especially in the AI space, efficiently? So that's why we are focusing on this unified platform strategy from ClickHouse itself. So I'm going to show you an actual live demo of this. So I've shared all these things, but what are we doing with it? We actually decided we should actually use it ourselves before going and talking a lot more about it. So we actually built something called Dwayne. Dwayne is a mouthful. But this is actually our database, data warehouse, where we are ingesting all information from observability to finance, operations. All information goes into this data warehouse that we have. So starting from our finance team, our CEO, CTO, anyone like VP of engineering, including security architects and everyone, they just need to go into this platform. They don't have to go through tons of Grafana dashboards or Superset or any kind of dashboards. They can just go interactively ask questions. We get access to everything using natural language. So this was our first setup. So if you look at this Superset dashboard we built on top of our data warehouse. But then we are a small company and we need to make sure that how can we maximize what we have already built. So we actually just created the MCP server and then plugged it in. So from the data warehouse just giving you the dashboard, we just augmented it with our MCP server, which you see at the bottom. That's not complicated itself. And we are using the MCP server from ClickHouse, and we're using an open source MCP client, which is LibreChat. And we already had this, what we call the Gen BI. As simple as that, just plugging this layer on top of our existing data warehouse. And now we actually have a very interactive chat interface, which does everything. Pretty much all of our internal business runs on this. So I'm going to show you a demo, but the slide actually showed our internal business data, but I'm going to show you the open version of that so you can actually test it out. So I already logged into this. So this is the LibreChat. It's an open source client. You can actually go and find it in the GitHub. So we have connected to our MCP ClickHouse server, and then this is going to query our SQL playground. So you can actually go and check this out. So sql.clickhouse.com. We have actually hosted a lot of data sets. Over there is large volume data sets you can actually go and query. But in our demo, I actually don't want to go and query any of that directly writing a SQL because I want to be as lazy as possible. So I can actually go and query this. Actually, I like the GitHub data quite a lot. So I'm just going to ask queries like, let's imagine, this is going to be a live demo. If it breaks, you need to excuse me for it. But just say, I want to see, draw a line chart with the top 10 repos. The last 5 years. So if you notice this, like the agent is actually thinking and is actually actively running queries on the database. So every time you see this actually runs a series of queries back into the database to figure out like, okay, because I didn't tell like which database to look at, which tables to look at or anything, because we already built the MCP server to like have all these different tools inside. So your LLM, which does the reasoning, is going to look at all of that, going to just ask, okay, what is the database I should be looking at? What is the tables I should be scanning for? And then is running queries, master queries on the database directly, and then building this plan for you. So while the LLM does this, you need you need to make sure that your data platform is able to support these requirements. So I'm just gonna go, so it's still running because as you saw, right, I have a lot of databases over here. These are all the databases, and each of this database, there's a lot of different tables. And there's a lot of data inside as well. I didn't really point it to anything. I just pointed to the database server. That's it. And now it's actually trying to scan through the entire database server, figuring all things out by itself. And then now it's actually writing the code. So it has already done the legwork and it's actually preparing the code for me to see the visualization. Yes.
Yeah. So let's say you self-host this kind of server, right? So you have to be able to get a response for this kind of query, you need like I/O, read from database, and also call the LLM as well. So do you have an estimate of the cost, like for each kind of request like this? Like how much does it cost for the company to self-host this kind of platform?
This is kind of like a brand new platform we just built, so we are still evaluating, trying to do the baseline of it. So we don't really actually have the costs yet for this. But one of the things about what we have built for the MCP server, right, not just the MCP concept of MCP itself, right, you can actually use your own LLMs. So then it becomes from a token-based cost to just a fixed infra cost. So you can actually just, for example, you can use DeepSeek's R1 actually to actually run all this. Now we are using Anthropic because I'm not running anything on my computer because it's ad hoc in also alpha phase. But then I've tested, initial testing on R1 has already been done. It's actually pretty good. So you can actually have a fixed infrastructure cost. So you can actually move away, like once you have established that we actually have a need, just put a fixed deployment of open source models, so it should be cheaper. And the other thing is, like, if you look at the whole space, right, it's evolving so fast. Like by the time like 6 months from now, like we might be talking about having all these models running purely edge compute. Might be just running inside your browser itself. Like we already have a couple of Gemini models that can be run within your browser that you download. So I'm pretty sure it's going to be even better. So this is a good thing with demos, live demos. As you see, like the line chart didn't come up, but at least the queries actually went and analyzed what's running. So like these are great, but actually one of this, I actually ran something on myself because this is a live data that's being ingested from GitHub itself. So I actually tested out some stuff. So I'm going to, because I'm active on GitHub for a while, so I actually decided, okay, let me check, like, does system track my commits, because this is a public data that we get from GitHub. So I just added my GitHub handle. So all I wanted to say is like, okay, look at GitHub, look for this person's, which is me, my GitHub handle, and just give a summary, like build an infographic of what I've done, what I focus on. So again, now I still have not given it any information on like what I'm looking for, like which database or anything. It's gonna like go through this whole process again. And then we are running this on a publicly hosted database. It's not like a specially custom tuned and dedicated database. It's just an open database that you can go and play around with. It's just gonna go through this whole process. So the whole point of this is like, I'm a single user who is gonna like use this application, but then the amount of requests that's gonna go to your database is gonna be multiplied by X number, depending on how complex your queries are gonna be. So that means you are not gonna be like designing a system which is unlimited scale. You need to have something that can run efficiently. So that's where kind of like ClickHouse plays a big role. So this will be the last query I'm gonna run. Let's just give it a couple of minutes for it to run and finish. And then we can show. I'm also still curious why the line chart didn't come here. Anyone who's really good at JavaScript can help me troubleshoot this later. We can actually check through this. Yeah, this is plain HTML with some JS. All right, while it's running, anyone has any questions or like what do you, like you see like something that you're doing differently that can be much better, like happy to hear from you guys of how you see things playing out for the AI space and how you're building it.
Waiting for the chat.
You're waiting for the chat to complete. It's going nowhere, man. It's gonna be there. Like, it'd be good to hear from you guys because it's kind of like me running a monologue, me talking a lot. Yeah, and you enjoy it. All right.
So maybe you can change the question to be maybe show like revenue of clicks how you run.
Oh,
Among the faster.
yeah. That's why I didn't do it. Like the screenshot I took from our internal data, because our CEO, actually he does not ask for analysts for information anymore. He actually goes into our chat. He just writes a query, like natural language. He asks like, okay, how many customers have you onboarded in the last 10 days or the last week? And how much have they, because we are a SaaS business, that means like, does not mean like customer signs up for $100 million, we get paid $100 million. It's how much the customer uses. So it comes almost near real time. As customers use our database, they are like all the credits gets consumed. So he runs a query, he knows exactly to the last minute how much customers have used. So this is done near real time, right? So like there is not dashboards anymore for us internally. So this system runs live for us. Let's see, it has been generating.
I have a question.
Yeah.
Maybe I don't know that I haven't read the agenda yet. So I don't know that you're gonna cover it or not, but like I would like to know the integration that you have right now. Like maybe like pulling data for Salesforce, Stripe, any popular platform like that can happen in instance.
We do have quite a number of integrations, which I will later come over and show you, which is all listed in our page, like website. But for the rest of it, it's more focused on like AI itself and also security, especially you do all this stuff. It's already hard enough to manage security with humans. Just imagine how easy is it going to be to handle security with AI. You have no idea, especially when the AI is doing reasoning like this. It's going to be thinking about a few different things. And it's going to be running a lot of different aspects of the database, and it's going to be like literally scraping through your entire database, the data warehouse. So that's when the last session is going to be around security, where San is going to cover in detail. So again, this is my GitHub portfolio, right? And it just helped me build and this is kind of like interactive dashboard itself. It's not an impressive GitHub usage, as some of you guys might have better commits and other repositories, but I was always impressed when I started using, to the point, the kind of things that I did. I just asked for an infographic, but then it actually went into like the top repositories I worked on, the technologies I focused, and everything else. And all of this happened real time. The code creation part is impressive, but then the more impressive part is the data itself, because it can actually say hello world for everything. But with having real-time data support and some system that can support it is where we see a lot of traction in the future as we start evolving in the AI space itself. So whatever I covered in the demo, like we have some of this already captured in our blogs, and our engineering blogs is kind of like pretty much every week one of the engineers writes a blog around like how do we do optimizations to how do we build applications, security, and all aspects. Feel free to connect. And also we have, this is one of the videos recently released on the MCP server usage. So you can actually check out our YouTube channel as well. And with that, all these things, right, you don't have to like have a massive setup. You just need this command. Literally, you can just curl the entire database. This will actually start the database on your system. All packaged literally, and you can run things at scale. Usually on my system, I actually run a few 100 million records of data, and like there's no issues on my Mac itself, so you can actually do a lot of demos, so it's quite efficient. And feel free to connect with our community, or also we have a lot of training programs available online free on our site. So with that, I'm going to finish my session, and I'm going to pass it to Nihat next. And I'm going to be staying around. If you guys have questions, feel free to come and find me, or during a lunch break, we actually have lunch coming in. You can also find me and I can address some of these questions. All right, Nihat, all yours, my friend.
Thank you.
Thanks, guys.